overall goal of this procedure is to demonstrate a microfluidic platform that combines resistive pulse sensing with code division multiple access to multiplex the detection and sizing of particles in multiple microfluidic channels.
This technology, named microfluidic codes, can help realize fully integrated and truly portable lab-on-a-chip devices that are well suited for the point-of-care testing of biological samples in resource-limited settings.
The main advantage of this technique is that it can electronically track spatial temporal manipulation of particles on the microfluidic chip, eliminating the need for an external instrument such as a microscope.
Our technology is compatible with soft lithography and can easily be integrated into a microfluidic device where particles are fractionated to provide a directly electronic readout similar to a Coulter counter.
To begin construction of the microfluidic device, generate a set of 4 7-bit gold codes. Then design 4 unique electrode layouts based on the gold codes using a computer-aided design or CAD software such as AutoCAD. Finally, have the photomask with the designed electrode layout manufactured by a photomask supplier. Next, soak a 4-inch borosilicate glass wafer in a 5:1 piranha solution at 120 degrees Celsius for 20 minutes. After cleaning, heat the wafer on a hot plate at 200 degrees Celsius for 20 minutes to evaporate residual water. Place the clean, dry wafer in a spin coater. Apply 2 milliliters of negative photoresist solution to the wafer and spin coat at 3,000 revolutions per minute.